Shilpa, working as assistant professor in the department of CSC. I would like to introduce today's resource person for the session, Dr. Girish Saunshi, sir. He has completed his engineering in the year 2005 from Navkis College of Engineering and Technology, Hubli, and masters from CMRIT in 2010, and he has obtained his PhD from VTU Belgavi in 2024. Sir has worked in many software companies, and he has total 4 years of experience in industry and also 16 years of teaching experience. Now, currently, he is working as associate professor in the department of CSC in the KLE College of Engineering, Hubli. Sir has published many national and international journals, and also he has 2 patents in his credit, and he has won a Best Project Award from the KCST in the year 2013-14 for the project titled Multi-Torch Reactable. And he is also currently is a member of Board of Studies for the Department of Computer Science and Engineering, KLE Society, which is accredited by NAC. And he has received many grants from the KCST and various other funding agencies. And also he has a book chapter titled Design and Comparison of Deep Learning Architecture for Image-Based Detection of Plant Disease, which is from AI and which is based on AI and IoT-based intelligent healthcare and sanitations. Thank you.
Thank you. Patrick. Thank you. It's my pleasure and honor to be presenting my knowledge with this awesome crowd of the today. And I'll be introducing my topic. The topic is leveraging artificial intelligence and meta learning for adaptive intelligence in agriculture. So, why did we choose meta learning and why I am focusing on agriculture is part of this topic today. So, before going to this, let's identify what is this. Cola. It's a cola. So, the people who are seeing it for the first time might feel this is a new animal. This is a koala bear, which is predominantly available or found in Australia. Okay. So now, what is this?
Oh, no.
Again, I'm saying koala. So, what made you identify two different positions of the animal, but you immediately found that this is the same animal? So, what made you understand that even when you saw it for the first time, and the second image was uploaded, and you immediately came up with the answer, it is a koala.
Features like nose, eyes.
Yes, features sir told the features of the koala bear, which appears to be the black nose, then round eyes, furry ears, then a rounded body with no tail, and its nails. So how we human identify it? We characterize the whole image into set of different features. When we look at the image, we look at the small features of it, where we separate out the koala eyes, we separate out the nose, we separate out the ears, and match that as the head of the koala, and we separate out the hands and the body, and we match out that as the body of the koala, and the different neurons of the brain again maps all of them to finally give me the conclusion telling that this is an koala animal. Okay, so this we found by one image. Accepting this, we don't have any training done, and we are not familiar with the animal, even though the second image was already told that this is itself the koala. So how did we do it? We are very intelligent, super fast. The brain of human learns faster compared to today's the focus, artificial intelligence or neural networks. What they do, the neural network goes under training process. One image cannot be one image if it learns go on learning. it overfits, it overlearns, and the same image with different perspective given will not be able to identify it. See this? What is this? And this is the number 9. So what I do is, I go on training this image to my neural network. I go on training the same image. And if I upload this image, what will our neural network do? Will it identify the image as number 9 or will it fail? What I did, I trained this image multiple times. Okay. And I gave that as an input to identify the image. Will my neural network identify it as a number 9 or it might fail? It fails. Why it fails? Because the position of the number 9 was identified as the 9 with the loopy surface, the vertical space and the diagonal spaces are in this particular position. It is going to map the position with the shape and the feature of that number 9. Okay, with that number 9, and when it is trained when it is tested with the same number 9 but with different position of it, it is trying to identify the position with the feature. The position with the feature, and when it is going to identify the position with the feature, it fails. Okay, so but as a human, we found that same image, we immediately found that this is 9 itself. We don't have any doubts on that. Okay. So this is what giving us the birth or the rise to meta learning. Before this, let's rekindle machine learning. What is machine learning happening? With machine learning, we have large data. We have diverse data. We don't have only large data, we also have diverse data. For example, suppose I'm training my 4-year-old daughter. What if I want to make her learn number 4? What I do is I train her. This is standing line, this is sleeping line. Again, this is standing line in 3 different positions. I am going to train her. Okay, once I train this and I give her this as the number, what happens? She fails to identify this as number 4 because she's learned with this and she's being tested with this. She fails. So what machine learning also does is training this, feeding this as a test image will also fail. So what we have to do? We have to train all sorts of possibilities. All sorts of possibilities for my machine learning to learn. So we need large data, we need diverse data along with different learning models, which might give me the broad generalization of the data. So this, along with this, we are also needing ImageNet. Yesterday, the second session was on DMNS data, and the first session from Dr. Ashok sir. They also have told the same thing, that we are going to need lot of data which are labeled images, and along with this, the deep learning model is going to train on these labeled images, and based on these diverse data, we are going to feed our network to learn on the specific particular data. Yeah. So apart from this, we also have GPTs. The chat GPT and mini DeepSeek and mini GPTs are already available in the market. So what are these GPTs doing? They are going to take the inputs, embed them into transformer blocks. Then based on this, they authenticate the data and give me. So what is GPT doing? It is fed with lot of large language models where they are fed with lot of data, including English, including Kannada, including Hindi. All sort of data are being embedded or learned with the GPTs. Based on this, we are going to learn the data. So ultimately, what am I going to speak is, in machine learning or deep learning, the focus is on large and huge data. Okay, what if I don't have large data? What if I don't have large data? So medical imaging, if anyone working on medical imaging or working on research, doing research on medical imaging, where if you are doing on cervical cancer or psoriasis of the bones or any particular medical imaging, if you approach a doctor, they decline. They decline, telling that it is a data which is very confidential and might not be given to any public. So they decline with the resources. So medical imaging, robotics, personalized education, even if we go and ask by to give your resources, they will not be giving the resources. So translation of rare languages or providing recommendations, there we don't have huge data. What do we have? We might get some scarce data or vast data available. They might be available in some resources, and based on that itself, we have to work out. But this machine learning, with machine learning, is not possible. What if we have general purpose AI system for the real world? I hope everyone might have seen the movie called as Teri Baatun Mein Ulta Diya, that Shahid Kapoor and Kriti Senan. Then Kriti Senan's movie, have you seen it? There is an female robot called as Sapra. It is Sapra is, I hope it is super intelligent female resource for automation. It is an robot made, and first Shahid Kapoor fails to identify it as a robot because Sapra is learning what Shahid Kapoor wants. So this is our general purpose system. The general purpose system is learning based on the adapting, it is adapting based on the requirement of the person. Based on the person, it is adapting and hence it is learning. So this kind of an possibilities is only possible if we are able to find out, adjust with the new possible data. Again, there cannot be huge learning cannot be happening. Once learned somewhere, once the knowledge base is available and kept in my database, then based on that learning itself, I have to process my data and learn it. So this is again need for continuous adaptability and learn the new job and learn everything from the scratch won't be helping us. And what if the data is having the long tail like this? The data is having the long tail where predominant data is not available, only the part of the data is available. So in such scenarios, machine learning fails to identify it. So please identify it. So we have the training data of the two artists. One is Brack and the other one is Cezanne. So I'm going to train you people with these and give you as a test data of that. Can we identify whether it is from Brack or can Cezanne?
Susan.
Any other? So as told, it has to be Cezanne. We are learning. So, based on these learnings of Bragg, we are going to identify what Bragg is doing, what kind of strokes Bragg is using, what kind of features Bragg is using, and we are also learning that Cezanne, what kind of Cezanne is working on, what vibrant strokes of the vibrant colors of data he's using. So based on these two learning, can we give our test as Brad or Suzanne? So for Suzanne, other friends are telling it to be Brad. Who is correct? Yes, it's Brad. And you people decided it to be Brad only from the images. Why? And how did we do it?
Color intensity and color combination.
Color combination, color intensity, and you might be also seeing there are strokes used with lines and patterns, curves, textures like no, sorry, patterns like lines. All the images of the graph, you can see it is in the form of lines, curves, pyramids, or triangles, or some features like this, which in our brain has processed the schooling learning where we usually use the drawings. And Cezanne is using the vibrant colors. There is no feature. He has used just the nature as his pattern of style of working. So based on these two artists, we our brain categorized it to be the brand. Agree? So this itself is meta learning. So from this, what did we learn is we learned that meta learning is a learning to learning. What is learning to learning? We have already the knowledge base available in our brains. We are trained with it, not on the same kind of data, but we have some part of training for lines. We have some part of training on curves and ellipse, eclipse, and every part of the data. We have our knowledge base, but based on this knowledge base, when we apply the same knowledge base on this image, our our brain extracted, the neurons of the brain extracted particular elements of that and gave us. We don't know whether it is 100% accurate or not, but 80, 70 or more than 50 at least, more than 50% of the images what we happen to see that it gave us that this might be a Braque image. Okay, so how did we accomplish? This is the learning to the learning, and this is how we are going to set the base for meta learning. So the interest for the meta learning started from 2017. It has come from 2017, and from last 5 years, it has grown into the huge potential. Why did it grow into the potential? Because deep learning and machine learning led us into hours of training or days of training. But this meta learning reduces our training process from hours, might be to some 2 or 3 hours or minutes. So this is how we are going using meta learning. Then let's learn what is this. Meta learning is described as a learning to a learning, where the aim of this meta learning is to create a learning algorithm that can quickly adapt to related tasks with less data. It is going to adapt with less data. Meta learning algorithms are using the meta. What is meta actually? When I tell meta, what is it? So meta means when I right click on any file, it gives me the properties. It gives me the properties. The properties can be the size of the file, when the file is created, and when who is the author of the file. All these data. The meta is also an important data of the particular file. Along with that, it is knowing all the content of that particular file. So it is not abstracting. It is the log data which the file might lead. Okay, meta learning algorithms are trained with predictions and metadata of other machine learning algorithms. See, it is in yesterday's class. Sir Ashok sir told that we have a bucket, huge bucket of artificial intelligence. In that again we have machine learning, and again in that we have deep learning. But meta learning is again within the deep learning. Okay, it is again within the deep learning. It is a part of deep learning, but what deep learning is doing, it needs huge data, but meta learning is learning from the deep learning, but with less data. Okay, so it needs the knowledge of machine learning, it needs the knowledge of deep learning. It has already built in all the data. The algorithms in meta learning, there are 5 to 6 algorithms in meta learning, and they already have learned the data, and they have their knowledge base ready with it. And what are we doing? We are just extracting the learned knowledge, applying it to the newly available data, and trying to merge the old data with the new data which are occupying, which are we are what we can tell is we are convolutioning it. The convolution of data, the predominantly learned data with the new data, we are going to superimpose it. Based on this learning, if the result is more than 50%, my machine is going to tell that it is the learned data. Okay, so this is how we are going to learn. I'll just read this out. Meta learning algorithms are trained on the predictions and the meta data of the other machine learning algorithm. Meta learning algorithms can generate predictions of their own and information that can enhance the performance and the results of the other machine learning algorithms. So it is going to enhance the result. Okay, so how it is done? We have supervised learning and we have unsupervised learning. Let's learn supervised learning. What happens in supervised learning? We are given with set of inputs in supervised learning, and with the set of inputs, we are going to apply some weights on it and some bias to it. Okay, based on the number of training happens, the algorithm is going to update its weights and the bias, and when it is finalizing its weight and the bias, it is going to give me the result y with the classification data what the data is. Okay, the same here, this is the meta learning data. What is happening? It is going to learn with 5 images, and in this 5 images, what am I going to test? I am going to test the completely unseen data of the dog's face. What it has learned in this 5 images, it has learned a dog with entire face or entire body of the dog, but given a face, will my machine learning do it? Yes, it does it. How it is going to do it? It is going to do it with the algorithm given there, supervised meta learning, where f of dtx where d raised to tr is already the knowledge base. It has the knowledge base. How it has gained that knowledge base? It has already gained the knowledge base from MNIST data, ImageNet data, then Kaggle, then with different resources available already, the algorithm is already learned. Okay, what are we doing here is we are just taking the known knowledge, applying with the unseen data, and processing it with the new training set, and my result y is produced with the learning. Making sense? Okay. So this is how, and we go on training all these data with giving us the test set, and ultimately when we test it, we are going to test with some unseen data and checking with the face of the lion and checking with the tumbler. So all these data are already fed, and once we know that, we are going to come up with the suitable answer. What is this? Okay, so how is this working? It has two phases. One is the training phase, the other one is the adaptation phase. In the training phase, the meta learning algorithms are trained on set of tasks, learning how to adjust the internal parameters or the architecture of the new tasks. So it is going to adjust. So as we learned the different weights and the biases, here also there are parameters which are going to be adjusted based on the new unseen data. And training phase adjusts. In the adaptation phase with the meta learning algorithm, it is going to adjust its suitable parameters based on the small amount of data which we are going to train the task. So how is this? Here we have the data and we have the base learners. The base learners can be anything. It can be your simple machine learning algorithms. it can be our deep learning algorithms, it can be any base learning algorithms, or it can be an algorithm which you have written with simple perceptron, with a single perceptron also can be possible. It can be any base learning algorithms. So what are we doing? We are going to feed our network with simple base learning algorithms. And with the base learning algorithms, what are we doing? We are separating out different features. As we did in the cola image, what did we do? We separated out an whole image of the cola with the eyes, ears, nose, body, and hands. Similarly, the base learners are going to break down the entire image into different learning phases. They are going to learn different learning perspectives of the features of the data given, and all those aggregated data are being fed to the meta learner algorithm. The meta learner will finally predict the data and give me the final output. So this is how your new unseen data. We have seen two images of the cola. Now we are seeing the third image of the cola, and ultimately we are going to tell that this is cola itself. But how our meta learning is going to tell? It is going to find the feature map based on the base learners. The base learners are going to take one feature of each of the image, identifying it as eye, nose, ears, hands, and legs. Based on these features, it is going to map the feature map, and the feature map is going to aggregate it as a head and a body, and ultimately the meta learning algorithm is going to predict whether this is a suitable animal. So how many types of meta learning are there? So these are meta learning algorithms where model agnostic meta learning, so MAML, MAML. So here there is a model given. With the model, it is going to segregate the suitable features of the model. Based on the features of the model, the meta learning algorithm is going to composite the data and give us the accurate data. So this model is MAML model is going to learn on the image input data. So it is going to learn on the image data, and image data is going to be segregated, and whatever kind of the image data, whether it is small data or huge data, it is going to identify based on the MAML technique. Metric based learning. Here we are going to learn based on the metric data. Metric data is the CSV data or any textual data. Based on the metric data, we are going to learn the algorithm. So based on our requirement, what meta learners are going to do? So we are going to use them. Here when we want to optimize the suitable algorithm, already available algorithm ResNet, VGG16 or any mobile net, any algorithm is already available, and we want to optimize the output because we are going to get the lesser output based on the given input data, and we want to optimize it. Then let's go for optimization based meta learner. And if it is needing the neural network with memory augmentation, we want to enhance the data which is already available, but the data is not huge data. We want to augment it more. Then we need memory augmented data where it processes its data capacity and learn it. And again, meta reinforcement learning. Here we have the agent which is going to decide it has wrong moves or correct moves. Based on that, the reinforcement data are learned, and it is going to decide the moves of that and assign the points to the learner. And based on these kind of data, we are going to learn this in meta reinforcement learning. Okay, these are 5 algorithms used in meta learning. Okay, so what kind of an input we have? Based on that input, the meta learners are going to work on. Each has different capacities. Every meta learning algorithm will not work on the same kind of an input data. If we have image data, then we are going to use MAML as the learner. If we have textual data, we are going to use metric based learning. If we want to optimize it, it is optimization based learning. If we want to enhance the data, memory neural networks, and if we want to work with unseen data, unsupervised learning, we are going to use reinforcement meta learning algorithms. Done? So let's focus on learning this metadata. How can it be useful in agriculture? So here, sir told us today that artificial intelligence has gone into a wrong diversion. Okay, so it might or may not be reducing the man force, but ultimately food is the requirement. Without food, you cannot survive, and hence meta learners can be useful in predicting the losses which are occurring in agriculture. Okay, so this is meta learning in agriculture. So how it is in agriculture in India? Not only this is paddy. This is